Hi, I'm Joe Roshetko. We're going to be working on our week 3 assignment today. My class is FTH 202 and my class number is 56574. Today is June 21st, 2025. First things first, I'm going to show that the firearm I am working with is clear. There's no there's no ammo in the chamber. There's no ammo in the barrel. There's also no ammo in my workspace anywhere. Everything's locked up back in the ammo cabinet. All right. So to start with, we're going to talk about the different failures that can possibly happen with the firearm. I'm going to adjust the camera so that way we can see what we're working with. All right. So to start with, we're going to talk about the hammer strut. That's this piece right here. All right. The hammer strut can result in a couple different failures depending on what is going wrong. All right. Initially, poor tension in the spring can cause the sear and the hammer not to come back all the way when it's being operated in double action. So when you pull, you'll see that the spring compresses. All right. Without the proper tension, the hammer's not going to come back fully to be able to engage the sear and allow the firearm to cock, hence having a failure to cock. All right. The energy isn't going to be there completely, and it won't fire. It also may not have enough tension to apply to move the transfer bar into place, hence not allowing the hammer to engage with the transfer bar, exposing the firing pin and causing the weapon not to fire. All right. So the two different failures you can have is a failure to cock and a failure to fire. All right. Second part we're going to talk about is the cylinder stop right here. Okay. Now its purpose is to retard the motion of the cylinder when it is locked in place, and when it's retracted during the pulling of the trigger, it's going to pull down and out of the way to allow the cylinder to rotate into place using these little notches here. All right, and once that notch comes into place and that cylinder stop comes up, it locks the cylinder in place so the next round is properly timed to be able to fire out of the barrel. All right. All right, if this isn't working correctly, that means that the cylinder may not, especially if it's worn down or broken, cylinder may not lock into place as it is rotating. All right. This is going to cause the two things possibly could happen. One, it could cause a catastrophic failure if the barrels aren't perfectly aligned, if the chambers aren't aligned perfectly with the barrel, causing the firearm to go off and strike the frame, causing injury to the person firing, or possibly damage to the firearm. All right, the second thing it can do is it'll cause the firearm not to lock. Well, that's a failure to lock. If it's not aligned correctly, also, the firing pin may not line up with the primer, hence causing a failure to fire. All right, the third thing we're going to talk about is the sear. All right. So in double action, when you're squeezing the trigger to push back on the hammer, all right, the sear locks into place here. All right. So when the firearm actually does cock, that's right. All right, and it locks into place, the sear engages with the surface here, causing it to lock into place. If the surface of the sear at this point here is worn, it won't lock into place. All right. It could cause the thing is, it could cause the hammer to skip that point, and then the hammer to drop when it's not ready, striking the frame, causing damage to the firearm. And if it does cause the hammer to fall before the cylinder is fully rotated into place, it could cause a failure to fire in that aspect as well. So that's a failure to fire and a failure to cock. All right. The last thing we're going to talk about is the hand. All right. So the hand is right here. Okay. The hand pushes the cylinder in a clockwise fashion, and if the hand is worn, it won't apply against the cylinder notches in the correct way, causing it to not be able to lock. All right. In aspect, so the hammer will be fully cocked before the cylinder's set, and then it is when it's locked into place, the cylinder won't actually be locked. It'll continue to move a little bit. All right. That's going to cause a number of issues, mostly including just like a failure to lock. All right. That's it for part one. For part two, we're going to be adjusting where we're sitting and going to put the pieces back on the firearm so we can properly do it. This is part two of my week 3 assignment for FTH 202. My class number is 56574 and it's June 21st, 2025. What we're going to be doing is we're going to be measuring the barrel twist rate of our Taurus. All right. So once again, there's no ammo in the firearm, no brass around my workspace. So we're going to need a few tools. We're going to need a set of digital calipers. We're going to need a cleaning rod with some blue painter's tape on it. One end marked with the flag, the other end with just some blue painter's tape on it so we can mark, and the attachment to put a cleaning patch. Gonna go ahead and slide the cleaning patch in, and we're going to insert the cleaning patch into the barrel of the firearm. Now, we're going to wait until we see this flag start to rotate. All right, we got a little bit of rotation. This is the point where we are going to mark the front end as to where the twist started. Now, we are going to slowly insert the cleaning rod until we observe the flag moving 1/8 of a turn, or at about a 45-degree angle from where it started at. Oh, and there we are. Now we are going to mark, mark the end of the cleaning rod, where it started to turn. Now, what we're going to do is we're going to take our patch, or our cleaning rod, and we're going to use our calipers to measure the distance between those two marks. And we are at 2.004 inches. So we're going to round that to just 2 inches. Now, in doing that, what we're going to do is we're going to take a blank sheet of paper and we're going to mark our numbers down. All right. So we know that we had 2 inches of play, or 2 inches of distance from where it was inserted till we got 1/8 of a turn. And we're going to multiply that by 1/8. You write that down again. 2 inches by 1/8. Now we're going to want a full twist. So what we're going to have to do is multiply these by 8. So we get 8/8, or 1 full inch, or 1 full turn, by this. So what we're going to get is 16/1, or a 1/16 twist. That is basically what the twist rate of our firearm is. And that about does it for this week's assignment. Thank you.